Developing IoT devices locally is very similar to developing any application. So you write some code, you build it, and you run it. The difference is the writing the code and the building it is on probably your development machine, and the running it is either in an emulator, which is a viable option, or the actual device, like this Raspberry Pi 3. Now, not every device works the same, so when developing locally for an Arduino, this is just an Arduino Shield, it's not a real Arduino, but the point remains the same. Typically, you'll just connect it through a USB cord, open up the Arduino IDE, write some sketch stuff, and then deploy it to it through a cable. Alternatively, there's stuff like this. This is the breadboard with a particle photon on it. And the particle photon has a pretty cool web-based IDE, or integrated developer environment, or development environment. And so you develop on a web browser in a server that's far away, and when you deploy code changes, it travels through the internet, through your Wi-Fi to the device. For the Raspberry Pi 3, if you're running Linux, you could SSH into a machine. You could probably SSH into a machine if it's Windows 10 as well, Windows 10 IoT Core. And then that acts as like a remote desktop, but without the GUI. So you're just sending commands and updating the device that way. So what are some tools I use for developing locally for my Raspberry Pi 3? Well, I'm developing for the Windows 10 IoT Core operating system. So I use the Windows 10 IoT Core dashboard, which allows me to create an operating system image and then put it on the SD card so that when I slot it into the Raspberry Pi 3, it already knows a username, a password, what version of Windows 10 it is on the card, and some Wi-Fi credentials so that I don't have to touch it once I stick it in the SD slot. So how do I know what's going on with it if I don't need to touch it after I put the SD card in and get it running? Well, I cheat by connecting my Raspberry Pi 3 to a monitor so that I can see what's going on. Or you could SSH into it, so that's like remote desktop but without the GUI, so you can see what's going on through the command line. Or in Visual Studio, I can find this device on the network and deploy to it, and then I can see what's happening through the console. So how am I developing an application that runs on my Raspberry Pi 3 that's running Windows 10 IoT Core? Well, I'm going to be developing it using Visual Studio, and I'm going to use a universal Windows application, because that's what runs on Windows 10 IoT Core operating systems. So how do I run this application and send it to my Raspberry Pi 3? Well, it's super simple. Let's just change some text, maybe make it bigger, maybe change the font, I don't know. Center the font up here a little bit. Hello, Bronco. And then let's go ahead and hit F5, or maybe just click the button because we're old school. And then we wait. And we keep waiting. We continue to wait while the application not only builds, but moves those beautiful packets through the internet. Well, it's actually just the Wi-Fi. And there it goes. It's just, oh. This is painful, right? Do we have to do this every time we make a change? Don't tell me we have to do this every time we make a change. From your idea to writing the code to finding out if it worked is a cycle time. And in general, we want to take those cycle times and make them smaller. Normally in development, when you run it on your local machine, by the time you see it working, it could be a couple of seconds. Whereas with IoT devices, because you're transferring the code typically across a wire or across a network onto a device, sometimes it's a lot slower. Because it takes so long to get code from Visual Studio to my application, to my Raspberry Pi 3 running my application, that's why I want to have unit tests. So I can do something akin to test-driven development and iterate quickly without having to move code from my host machine to my device. So no matter what you choose for your hardware, no matter what you choose for your operating system, no matter what you choose as far as a language or a platform to develop with, reducing that cycle time is a key component to being able to move quickly and not waste a bunch of time just waiting for code to get from your host machine to the device itself.